Good morning, everyone. Let's see if this comes up. There we go. My name is Ante Lausic. I'm an additive manufacturing engineer at Exco Engineering. Exco is a high-pressure die-cast tool builder. So we design, develop, and manufacture tooling for structural components and powertrain components in the automotive industry. I'm here today representing the additive manufacturing side of our business, which focuses on designing, developing, and manufacturing small conformally cooled inserts, but also larger ones up to about 100 kilos in weight per part. And the additive manufacturing, advanced manufacturing link is very prominent here. So the idea that I'm kind of pitching today is one that we just last week won the 2019 PACE Awards for our hybrid 3D printing additive manufacturing technique. This is basically like the Oscars for the automotive suppliers industry, so no one really cares. What we won the award basically for was a hybrid technique of repurposing tooling. So in the image there in the inset, it's kind of hard to see, but it's the traditional additive cycle for us. So we start with an insert, design a conformal cooling line, run through simulations, manufacture the component with our own in-house printers that we developed with EOS, and deliver these to our customer. This tooling lasts much longer than traditional tooling, better casting properties, lower downtime, lower scrap rates, and it's all across North America now. So that was great, but we told our customers when you're done with the insert, even though it's lasted much longer than a traditional insert, send it back to us. We'll repurpose that insert for you. So what that meant was removing the portion of the insert that was used or worn away, and then rebuilding that with the same technique that we built the first one with. What this meant was the lead times to get a new part were drastically reduced, and the cost to both the environment and the customer and to us was also greatly reduced. Now, that works for our smaller scale machines. Those are about 400 by 400 millimeters in size. They're still the largest tool steel printers in the world. What we build as a shop is things on the order of meters, and so we're looking at ways of doing the same technique on a much larger scale. Can we repurpose 1,000-kilo inserts that we build in our shop? People have seen direct energy deposition and other deposition techniques to deposit material, but it's only a very small amount. What we need is to be able to remove massive amounts of steel and redeposit a high-quality steel back on top with the conformal cooling. That's going to be the hardest part of this project. So just a little bit about why we need to do this is these inserts, traditionally 1,000 kilos, come back after 60,000 shots and go straight into the garbage for pennies on the pound. By being able to repurpose the entire base of that, which is more than 80% of its weight, it's a huge cost savings to us and a much quicker return of that rebuild on a preventative maintenance cycle to our customers, whether they be FCA or GM or the NEMAX all over North America and Europe. So who we're kind of looking to partner with on this, the big one right now is CT and X-ray scan, an ability to look at the used insert when it comes back to us and identify what areas need to be removed and what areas do not need to be removed. And it might change from an insert to an insert basis. Do I remove a full 2 inches from the insert or just the outer surface? And then we probably need a specialty powder. We've developed a powder that we use for our inserts, but for hybrid building on top of this larger insert, it might not be the same material, or it might be the same material in a different form. There's also obviously the deposition machines that exist on the market and those manufacturers, but it doesn't need to be deposition. Whatever technique works to get us a large volume deposited on that base. And then finally, casting, molding, and stamping companies. We have a lot of customers obviously in the US and in Europe. What we're looking for is Canadian content and people we can work with in Canada in those fields that we can sample this technology on. So that's all for me. Thank you.